So, going to do the entire rocket stove project. So let's just bring this in here. Rocket fire. So this is what we're going to draw here, and you guys should have a copy of this. So basically what I'm going to do is I'm going to go through and just do the whole project. So first I'll draw up all the parts, and I'll assemble it and put it on the paper and put all these bubbles on and all that sort of thing. So I'm going to move that to my second screen. So hopefully you guys have that copy in front of you. I might drag it across sometimes, but not that often. So I'm going to go up to New, Sheet Metal, IPT. And first thing I'll do is go into Sheet Metal Defaults. And I'll change this to 3mm. The whole project is in 3mm unless you supply something else. And we'll start a sketch, and I'll just do XY. So what I'm going to do here is just do the back face. So I'll do 2-point center rectangle, and we're going to do 200 by 500. And that's going to be the back face of our rocket stove. So that'll be this part here down the back. Then fold these two sides out. So first thing, go finish sketch and make a face out of that back there. Follow defaults is fine, and it doesn't really matter, it can go either way. And close that one. Now the overall length of this thing is 500, so it's 500, 500. That's just including those little grill plates up there. So what I'm going to do is go to flange and try and make sure they both go the same way. A distance of 500. I'm going to click on the top here and just check where it's coming from. So that's going to go back to that edge there. So the overall width will be 200. So that's what we want. And we'll go apply. Now I've got our two flanges there. So I'm just going to check. It's always a good idea to check this. I'll go and spec measure, and I'll click on the edge in the outside there, and you can see it's come up 500. So that means the overall length is 500. So that's good, that's what I want. And I'll just rotate it around to the view that I'm familiar with. And what I'll do is I'll click on this corner here, right click on this home, I'll set current view as home, fit to view. And you can see my top is around this way, and this should be my front. So yeah, I'm quite happy with that, how that's laid out. You can always change them if you're not. Now I'll go back to the tab here and go start sketch. And what we'll do is project geometry. So we'll project the outside lines, so just be careful not to do the end line here. And you might as well do this one and this one. This side, this side, and this side. So now what I'm just going to do is roughly draw in the shape of what I want. So nice and rough like this. But the main thing you want to check there is that they're all a connected line and they connect to these ends here. Now we can use some constraints. So if we use horizontal on this line, make it horizontal, make this one vertical. You can see how it's sort of come off that line there. So it's always something you've got to keep an eye on. So I can go to coincident constraint, click on the end, and click to the line, and I'll make sure it stays on that line. And I can also try and grab the end of this line, see if it moves anywhere. So it doesn't want to go off the edge, so that's good. And another thing we can do is go equals. So we want that, and that equal, we want that, and that equal. we want parallel, we want this and this one parallel, and perpendicular, we want this one perpendicular to this one. And we have a look at these pictures here. So we've got a 125 long, so it's 45 degrees, and a radius of 6. So let's put that on there. You see here, I just clicked the dimension, then clicked off to the side of it. So I'll do that again, just so you get a good view of it. If you don't bring it close to the line and then click again, it won't do the angled measurement. Let's see if we need a 45 degree here. You do. And this is 200 overall, 200 square, so we'll do, but I don't want to do that quite at 200 yet. I want to do it at 197 because I'm going to be adding a layer on top of this, so that'll add up to 200 when it's got that layer welded on the front. And you can see down here it's fully constrained, so that's looking good. The last thing we'll probably do is, might as well do some fillets, 6mm fillets, and should be good. So you can see I've only actually had to use 4 dimensions on that, the rest of it's just with constraints. So we'll go to finish sketch. Now what we can do is go cut that all. We go all, make sure it's going the right way. Or if you're going to use the all option, you can use the 2-way option and it'll cut for everything on the screen. So there's our basic shape there. So let's have a look at the drawing again. And we've got these slots which are 3.1 by 25. So it's a bit of a clearance for a bit of free-mill plate there. And they're just like evenly spaced here. So you see there's 60-60, and that'll be from the center. So there's a little bit less on this bit because it's going to have a layer on top, and there's a little bit more to the fold line. So let's put those in there. And yeah, if you're thinking I could have done them in that last drawing, you did right, I could have. But it's fine. We'll just do it onto this bit. One advantage of doing it this way is we can project this cut line here, and it gives us a, it's a bit easier to work with without having the rest of the drawing on there at the same time. So now I'll just roughly draw in some rectangles. Just got to make sure they touch that line there, that's all. And another thing I'm going to do is put some construction lines in. So I'll turn that construction line on up there. Line, top. And I'm only just doing this so I can dimension to them because we've got center dimensions, the slots there. So now looking at this, I can see this line's black. So it's grabbed that center point there. So I don't actually want that to be the case, so I'm just going to delete it. I can go through and change the constraints and everything, but sometimes it's just easier to delete things. I'll drag it out the way approximately where it's going to be. And see, I still had it in construction there, so if I just click on that line and take construction off, it'll change it back to a normal line. Then you've got to remember to come up here and just undo construction there at the top. Otherwise it sort of turns itself back on after you change it. So now I'm going to just make sure we've got equal lengths here, equal lengths here. So they're all equal off each other, so if any of these changes, they'll all change. That's kind of chained back to that one, that's chained back to that one. I'm going to dimension this length here to half of 200, so we'll go 100 and go 60. And another thing we could do here is dimension between these two, and I can put in equals that dimension. So if I change that 60, decide I want them further apart or closer together, I can change it. So say 40, we want them at 60. I'm just doing it for a bit of a demonstration. And the depth of these is 25. See how because they're all horizontally constrained, they followed each other. And the width was 3.1, so it's a clearance for the plate that's going to go in there. Right, so that's fully constrained. Let's go finish, and we can go cut. Grab those shapes, they highlight very lime sort of green there. Cut through all. And you can see the arrows going that way, so it's going to cut right through everything. So that's your main body part there. So we'll save that as same name as this one. So rocket fire dash body. So that's your main part there. So I'm going to look at doing these inner parts next. I'm going to do it a bit of a, maybe a bit of a strange way, but see why when we get there. So let's close this. And now I'm going to do a new sheet metal. Now if I look at these drawings here, got that, where is it? There they are. So they end up being 392.8 by 140.6. But we do know it's a 45-degree fold on that part. So what you can do is you do a few measurements and find how long you want it to be. Or we can do what I'm going to do here. So yeah, start on the XY plane and center point rectangle again. Now I want it to fit in between the two sides, so, or maybe overlap it slightly, because I'm going to fillet weld it together. So maybe I'll do this at, say, 196. That'll mean it'll overlap a mil on each side. Maybe let's do it 197, so a mil and a half on each side. And tab, and lengthwise I will just say 500, because I don't know right now. Same thing as before, go to your sheet metal defaults, use thickness from rule, change it to 3mm, make that into a face, apply, close, and come to your flange up here, change the angle to 45. Well, you see it's 45 up from straight, so we actually want 135. So folding back on itself. Bend radius, that's your internal radius, so we have it at 3mm, what we're doing here, and say a length of 500 again. Okay, so you can see we've got like a quite a long bit here. So we don't know exactly where to cut it off, so there's a couple of things we can do here. We'll save it first. And that part is the, on this one, is called the mid plate. Save. Right, so now what I'm going to do is close out of that, and I'm going to go into a new assembly, standard millimeter IAM. Drop down this bit here and go place, and we'll go to that main body there, put that body in, just click on there, and you see it's brought it in sort of upside down, not really the way we want it. So let's see what the home view is. This must be the home view. Right, so what we need to do also here is we need to constrain this part to the origin of this assembly. So I've got this origin here. There should be the origin of the part. No, that's the origin of the part there, sorry. And that's the origin of the assembly space. So all we'll do here is just go constrain x, yz to yz, flush xz to xz, flush xy to xy, flush like that, close it. And I'm also just going to see what the home view looks like. Yeah, it still hasn't changed, so I'm going to rotate this round, and I want it to be in sort of this sort of view for my home view. So I'll click that corner and go right click up here and go set current view as home, but to view. And now if I double click on that middle button, it zooms into it like that. Another thing I like to do in this zone is go to view and change it to shaded with edges. Just makes it easier to see what you're doing. There is a way to automatically do that, but I'm not going to go down that road for this particular thing. So now let's go place and put in that mid plate there. Right, we're just going to do one. You can see it's way too big, obviously, but we didn't really know the length of these bits. So what we'll do is we'll constrain this face to this one as a mate. We've got a mate there, see? And this, we go on the inside of this bend radius here, click along that, and then we can along that, and we'll put it in the right spot for our drawing. Now, at this point, you can still move this way and this way. So there's two ways we can do it. We can do a constraint from this face to that face and put an offset of 1.5. So it'll be centralized. Or the other way we can do it, we can drop down these bits here. And we can go to constrain, find the plane running through the center of it like that. Got that one. And we've got that one. So go back to constrain again. That one and that one. So it may be flush, it may not be. So yeah, flush sort of brought it together. There you go. So now it's centrally constrained to the origin planes here. That's always a better option if you can use it. It means if you change the size of anything, it'll still be centered. You see now we've got a bit that's obviously way too big. So what we can do is we can double click on this piece, start a sketch on this piece. And what I can do is project this point. Say we want to cut it to this point here, and we can project this whole face as well. And I'll just click on this cube so it squares up to it. Now what I can do here is drop down your rectangle and go to, say, a 2.1. start there and finish across from that point. And see, it's still blue, so it can go up and down. But if we put a horizontal constraint from that point to that point, it'll follow this this length here. So if you did change this length, this bit would cut as well. So let's go to cut that bit off, and we'll just leave it at thickness there. And let's do the same on this bit here. So let's do sketch and project geometry. Just do that point again, and this face. Do a rectangle, and make that horizontal to that point. Like that, and go cut. And so the reason I've done that is to show you these, this is quite adaptable, this program. Right, so you see how this it's cut to the right length now, so now we can bring in another one of those bits. And just constrain it the same way we did before because it's symmetrical. So we'll go a mate from that surface to that surface, straight mate like that. And now we can do flush. Grab this face. Flush to each other now. And I'll do this a different way this time. I'll do flush to flush. And it needs to be 1.5, so I'll just type that in. You can see how it's recessed it back 1.5 there. So now we've got like a fillet that we need to do on that. So that's those three parts there. So the reason I did this whole cutting thing is just to show you. So what I'm going to do first is I've got to save this. And I'll call this the rocket fire. And say used to all. Okay. So now if I say close this, and I want to open up that mid plate again, you can see the size has changed. So working in that assembly space, we've actually trimmed this part down and go to create flat pattern. And there's our flat pattern for that part. So it's all interlinked with each other. Right, so I'll close out of that one. The next bit we need to look at is this base bit here. That's the base bit there, so it's just a bit to fit in the bottom. It's going to be welded on like the rest of it. So let's draw that up. New sheet metal. And send to rectangle. So I know I want it to be 197 wide by 500 long. Ish. So I know that's what I want there. Without going at it and measuring everything. What we can do here as well, same thing, go 3mm. Make a face. Yep. Save that as the rocket fire base. There's our base part, so I'll close this again. So one thing to note is I always close out of everything I'm doing. I don't just keep opening windows, because what happens is you'll change something in one window and then it doesn't really know which one to overwrite, or it can confuse you at least anyway. So it's better just to close out of everything and just work in the one space at a time. Don't have a whole bunch of tabs up here, unless you know what you're doing, basically. So now let's put the base on the bottom here. Go on that. And I'll go mate it to the bottom. Apply. And I'm just going to do that same sort of thing I did before. Flush there to there. Flush. And 1.5, because I've made it 3 mil shorter overall, so it overlaps each side. Apply. And make these flush here. Flush and flush. Now you can see it's sort of sticking out the bottom a wee bit. So we obviously want to, you could probably just weld that and grind it back, but it hasn't got that little lap on the back either. So we need need to cut this back a wee bit, so we've got a bit of root pass on the weld there. So let's double click on that and start a sketch on this one. And we'll go to project geometry again. So if I rotate this around, and I have to do it right around like that. If I click on here and here, they come up on the side. So I'll just click on this to screw it up again. So there's your corner, and we want to project this edge as well. So if we want 1.5 all the way around, we're going to have to offset that line there. So let's go to offset. 1.5. Same thing with this one. And I'll just connect those to a line here. And the other thing I'm going to do is I'm just going to make sure I've got this space filled in, because cut can be a bit funny sometimes. So I'll just draw a line from there to there, all the way down, and off to this bit here. And we'll go cut. And yep, so it's already picked up on that bit. Free thickness, that's okay, cool. Double click on this bit so we can see it again. So now we've got 1.5 mil all the way around. Obviously you could have just drawn it right in the first place. You knew your measurements. I'm just trying to demonstrate what you can do with this program. So here we go, we've got the main body now. Let's save that again. There's just a few more things to draw, so let's close out of that. You've got the little gruel plate things here, which are called slates on this drawing. They're 50 by 200, so let's just do that nice easy one. Just change that to center point rectangle again. It's just a quick one to use, really. Don't have to bother constraining it most of the time. And we'll save this part. Save this as rocket file. Close out of that. In the last part, we needed these little feet. So say you got this, generally speaking, you draw it in 3D, then flatten it to get the pattern for it. Let's say we're just going to use, we know what it is flat, but we don't know what it is, it hasn't got dimensions on this way. So we can just draw that and then fold it from there. I don't usually recommend drawing the flat and then folding it. It can be right sometimes, but it loses all the adaptivity. It's generally not the way you would do things, but just going to do it here for a bit of a demonstration what you can't do on this software. And dimension, let's go back. We had 124.4. And width we have 40, was it? 30. 124.4 by 30. And let's put these holes in it, eh? Why not? So they're down the center here, and we've got fold line right there, 15.8 and 25. So let's do the fold line. We'll do that as construction. Then take that off. Take it out of construction and do your 2 circles over here. Now let's just do an equal constraint on those so they're the same. Horizontal, and then horizontal to the origin there. And let's have a look at the drawing again. So they're an 8mm hole, 74.7 to the fold. So let's put those numbers in there. That was 15.8. And there was 25 between them, if I remember rightly. Nope, that doesn't look right. Must be 15. No, it is 25. Nope, that's fine. Oh, doesn't look right because the whole diameter is not put in there yet. So put that in at 8. That looks a bit better. Let's finish that sketch and make a face. So click on this bit and go apply. You can see it's not the right thickness here because I haven't done this yet. So it's come at 0.5. So at any point during the drawing you can change this. Always best to do it at the start though, because you might find you have some errors if you do quite a few folds and things. I've changed that there. Now what I can do is come over here to this face one and this sketch, and I can right click it and turn that visibility back on. Now I should be able to go up to fold here and click that line. So the line has to be on the surface. So if I didn't put that in there in the start, I'd have to come back and draw that on there, but it's fine how it is. You can see you've got direction and what way up and from out what face and all that sort of thing. So I do want to kink it out that way. Let's have a look at the arrow. That way, and I'll keep this bit flat to the plane, just in case I need to use that to strain it together. So the angle, said it's a 160-degree angle, so that works out to be 30 degrees upwards. We'll go apply there, and that doesn't look right. So my maths is bad, so you can come over here, click on this thing in the design browser there and edit feature. Let's put it at 20. So that's better. Now because I've used that, I've turned that visibility on that sketch because I needed to use it. I have to just come over here and turn it off again just to hide it. Otherwise it'll come up on the assembly and everything, and so just a bit annoying. So let's save this part. And on here we have called this foot, which sounds pretty good to me. Foot. And let's go back to the assembly drawing. Let's open that back up. And first thing I always do is go to view, shaded with edges. Now let's put in the slates here. But where are they? There it is. So we need 3 of them, so I'll just click 3 times. And I can start by constraining these all together. So if I make them all flush on that end to each other, they're all flush that way. So these are all joint together now. So if I move them around, you can see they still move like this, but they're all flush on those 2 faces. Now what I can do is turn this around and just see the bottom of it. And let's do a mate from that surface to that surface. Now they're all constrained that way. You can see they can still move around a bit. So we knew the gap was 60 between them. 60 centre to centre. So if we take 3 mil off that, we'll end up 57. So let's do a mate and do 57. Like so, between those 2. Same thing over here. Now we've got the right spacing, or we should do. Still move these around. So the length, for whatever reason, I must have done that wrong. So let's have a look at the PDF again. 200. Oh, right, yeah, okay. So this drawing is actually a bit smaller. Doesn't really matter. So let's do them a bit bigger. So I'll make that, double click on that and go. Edit that sketch. Let's make that 250. So this is actually slightly bigger than the example one. Just I screwed up the initial measurement, but it doesn't really matter for what we're doing. Just showing you the techniques of how to do it. So if we've got a width of 200 here and a slate at 250 long, we're going to need 25 sticking out the side. So let's go flush there to there. Let's run away. See it's over there, and we'll put 25. So it should. See it moved back. So we want to go minus like that. And last one we'll do is we'll do this face to center, and that's going to be half that width back, so it's going to be 100 plus half of the width of the material, so 101.5, and we'll make sure we put a minus on there just because of the way it is. There you go, so those are placed properly. So there's a lot of ways to do this. Straining, the main, when you get into more advanced things, you'll want to do it with adaptability in mind. So you want to be straining things in a way that if you change certain sizes and things, it'll still make sense and will still join together. Really doesn't matter how you do it as long as none of it moves. Because if you go to change anything, it's going to all fall to bits basically. Or even if you drag it. So you've got to make sure it's all joined together. You shouldn't be able to grab any of these bits and move them around. And the last thing we need to put on there is the feet. So let's place the feet, the foot, and we need 4 of them. So there's 1, 2, 3, 4. So I'll just do these all individually, just give you a bit more of a demonstration of the constraints. Let's go mate to mate, and we'll do mate to mate here as well. Then now I've kind of buggered it up because it's stuck, but I can always go back to the bit that's highlighted green over here, and I can edit that. So there's one mate, those 2 surfaces that light up, and there's another one. So I can edit, and then I can say minus 50, go OK, and it should move it up. There you go. So you can always come back and change these mates later, or else you can go around if you've stuffed something up, it's just not doing what you want. You can just click on any of these and just hit delete or right click and delete them. So I want this foot to be, say, 50 mil from the back edge here, so I'll go click on that, go flush, type in 50, and it's come 50 mil off the back. Apply, cool. That one's where I want it. And now I want the other one on the front as well. So let's do that. Strain this one as a mate. So now I've got this at the right height, I can use the top of that one. So if I go flush there, flush there, now they're going to be on the same plane as well. And let's go flush and flush and type in 50, so it's 50 back from the edge. See how it's sort of jumped out? So depending on what you click first, it'll move one way or the other. So I'll go minus 50, and now it's 50 back from the edge. So now what I'm going to do is we've got this thing, we've got the legs on one side, so that's where we want them. We're going to do the same thing with the other side, but I'll just do something a bit different to what you'd probably normally do, but it's going to work out good anyway. So I'll double click on this body, and I'll start a sketch on the face of this. Now you see how the rest of it's sort of gone clear. It's still there though. So if I go project geometry and I just hover above where those holes are, go finish sketch, now go to cut, and I'll just select all the inside of these holes here, and we'll go all, and the arrow's pointing through that way, which is right. And now you can see that bit, we've cut the holes right through the whole thing. So I can use these holes to align those other 2 feet now. And so 2 things you can do to get back. You can double click on this bit here, or you can hit return, and that takes you back to the assembly. Right, so there's your feet constraint on that side. Now let's attach them on the other side. So now I've put those holes right through the whole piece, so I can just go constrain there to there as a mate, so it'll stick on the surface. Then I can just mate through these axes here, so that top hole to the top hole, bottom hole to the bottom hole. There you go, that's where it should be. Mate that to that. There's a mate there. Do the same thing for this other foot. Top hole to top hole. Bottom hole to bottom hole. So there you go. So there's the whole fire, rocket fire put together. Let's make sure we save it. Right, now we've got the complete assembly here. So part of this project as well is we need to do an exploded view. So there's not one in this one that's been added since last time. So what we need to do is we need to close that, make sure it's saved. And we'll go to a new IPN, this inventor presentation file, and automatically prompting us for the model, so let's find it. So there's our rocket fire there. So same thing again, always go to your view and shade it with edges, make it a bit easier to see. Now the thing we've got to think about here is this thing is you can do videos with it. So I could do a video of these, you know, coming in one by one and these feet going on, and I could even, you know, put bolts in there and have them turning as they go in and everything like that. We don't really need to do that. All we need to do this one is just do a exploded view. So we need to think about what sort of way when we look at this is going to be the best for showing as many parts as possible. So, you know, sometimes it's a easy pick, sometimes it's not really. And sometimes you don't want one of these sort of angles you can just pick from up here. So what I quite often do is I will turn it round to where I, you know, just where I want it, maybe something like that. And I'll just set that as the front, or you can use snapshot view or capture camera, and then it'll save that orientation. Because you always want to, so with this IPN, you want to think about exactly what side you want to look at and how you're going to present it, because everything on the paper is going to be looking at it from that one view as well. So what I'll do, just to make it easier, is I'll click on that corner and I'll just use that view there. And I will use everything in this way, so I can explode it like this. So what we can go up to is tweak components here, and you can grab a few, hold shift, and you can grab a few things at once. And you got your arrows here. Ideally you want to drag it to the right place first. You don't want to drag it around and then back again, because it's going to leave these what you call trails. And just go 82, and I'll just agree with that. That looks fine. And say tweak components again. Let's do this one. And you can see how it's sort of gone to its orientation from its original drawing. So it wants to go out that way. So I'm just going to put them out this way and do the same with that one. There you go. So those are out the way, and then they go, you know, obviously they come back into here. Let's tweak this bottom piece, and we'll drag that down to show that it goes up into there. Make sure you press enter. So you can put in an exact amount, but you can just drag them to where they look good, which is what I'm generally doing. Shift and grab two of them. And this is where it can be a bit tricky. So you can't see those bits on the other side. So what I'm going to do is turn that around, tweak these two, holding shift, so grab both of them, and then pull those quite far out. Then I'm going to get to my view that I want them on. Then I can adjust it there, so I don't want it to go that far. If I put them just there, I can see everything through this side, so that'll be perfect. So it doesn't really matter if they like overlap or anything like that, as long as you can sort of see each individual part and that it's not attached to another part. So I'm going to save that, and we'll just Rockify assembly IPN, save. So that'll be our what our exploded view looks like. So now I can close out of this one. Now what we want to do is we're going to do all the laying out on the paper, so we're going to make it all look like this. So this is probably the most time consuming part of it, or can be, depending how good you are at drawing and things like that. So let's get that underway. So you want to go to a IDW, so I'm going to do that one, R third angle, which is the one I've given you guys. Just something to note is if you ever jump on Inventor, its standard template is like a off-white. It pays to go in there and change it if you can figure out how. Just so when you draw something, it's a white background. That way you can, put it into another sort of document and it doesn't have a big orangey square around it. It looks good. Anyway, so if we go into here, we go base, and we can search for rocket fire. So let's do first page. Let's do the exploded view. And there you can see it's coming the way we had it. And let's just play with the scale values so it fits in nicely. So 1 to 5, not too bad. 1 to 4, that looks pretty good to me. So I'm going to move it slightly left anyway. And I'll make sure it's shaded, solid. And we'll go across here, display options. So you can put Fred feature on there, so we don't have any Fred, but make sure tangent edges is on. It just shows the folds nicely. And yep, that's everything there. I just was looking for that. So show trails, so it's going to show these lines, so it knows where it came from. Let's go OK to that. And there we go. So we've got the exploded view on a page. Now we want to do a parts list. So we'll go up to annotate and do a parts list. Select the document, select this rocket fire assembly, open, and go OK. OK. You can drop that in there. So now you can see we've got all the parts and the quantities. So that's nice and easy, really. So the only thing I'd probably do in here is I double click on this thing and put in 3mm mold. 3mm mold steel. Just description. You can put anything you want in there. You could say, the overall cut size or whatever. Yeah, it depends what you're doing it for. I'll just put that in there just to say that's the description. It's 3mm mold steel. I could put much more details in that, but I don't really want to. Now we can do balloons. So if we click down here and go to auto balloon and click on this view, select view set, add or remove components there. Yep, around. I generally will go for a round like this, and just make sure you've got everything selected. So just go through and click on everything. We can always delete them later. So obviously you don't necessarily need a bubble for each part. And you go select placement there. And we'll go something, I'll just click there. Doesn't really matter. Go apply. Now, what we want to do now is just drag these to places that make sense. So you can actually grab the end of the arrow here, and I'm going to grab this one, and I like to put the arrow in the center of the piece so you know exactly what it's pointing to. The edge can be a bit frustrating, so let's just have a look here. The slate's number 4, so that arrow was actually pointing at this main body, I think. So let's drag that and make sure it's bang in the middle of that body. So you know exactly what it's talking about. It's talking about the body, part number 1, rocket fire body there. And let's drag this one, number 2. Drag that endpoint onto the piece again. So there's no mistaking what part that is. Same with this bit. Straight onto the piece. Yeah, as far as like rules for this, it's really just trying to make it as clear as possible. So it's up to you really. I mean, you just put them where it looks about right. Make sure it's just make sure it's obvious what it's pointing to and make sure everything's got a bubble around it. Like that. So there's your trails, there's all your parts, there's your parts list. So that's pretty easy to do. And scale, let's fill these in. So you can set up your template so you type in these individual bits, or else what you can do is just use text boxes. That's what I've set it up for here. So I'll go to say a 5mm text. Scale is, if I remember rightly, 1:4. Okay. Designed by me. And the date today is the 31st of the 8th. What's it saying here? I'm not sure. It's just saying it's not happy with those division marks or something like that. I'll drag over here and just make sure that's 5mm high as well. And in here I will put the name, make sure that's 5mm. That can be the rocket, fire, exploded view, easy enough. And last one we need to do is click on this and go sheet 1 out of, so I don't actually know yet, so I'm going to guess 8. So we'll put 8. I can always change that later. There's your first page all ready, all done. Now what we want to do is go out to your place views again, and we just want a new sheet, new sheet, new sheet, new sheet. So you've got 8 down the left there, and go back to sheet 1. And what we'll do is we'll hold shift and we'll grab all these things here. Control Z, Control V, and we'll just place them on each sheet. So I'll leave these, I'll fill out these as we go. So, right, so we've got our 8 sheets up here. So you can name these sheets if you want. So if I click in that box, so that name will actually come through when we put it as a PDF as well. And sheet 2, we're going to go assembly. So let's do the assembly view. We're on sheet 2, and let's just change that to a 2. 2 out of 8. And we'll just make sure we get the scale when we bring it in. So let's bring in the, up to here, go to base, go to the actual assembly itself. And what's a good thing to do is always put a, you can figure out what corner to click on. Put a small isometric up in the corner, top corner. 1 to, let's say 5. So just put that up to the right hand corner, make sure you turn the shading on and the tangent edges are shown. Chuck that up in your right corner there. Generally people will put an isometric up towards the right like that. Let's put in the front, top and side view now. But let's get to that rocket fire assembly again. And I'll see if we can fit it in 1 to 4 like we had the other bit. See if I click on this arrow here, bring a view out to the side. So you've got your front, your side, and I'm not really going to be able to fit the top view in there, but that's okay. We can get away with just the those 2 views there. Same thing again, make sure it's shaded in, make sure your tangent edges is on. Now you've got these views, they're linked together like that, which is good. Now we want to do some overall dimensions, so I'm just going to make a bit of room for the dimensions here. Up to annotate and go dimension. Sometimes it can be a bit tricky. If you click on a couple of points, it might do a real weird angle, but it's worked out right now. So we've got 597 basically. So all I'd do here is probably just change the primary unit to 0, maybe even override it, say 597 is what it's kind of supposed to be, but let's just say 600. It's going to be about 600 by the time we assemble it, and allowing for, you know, a bit of growth here and there and whatnot. That's up to you if you do that. This, the reason I made that slightly bigger is because you'd probably, this would be the information for like the people we were packaging. So you'd want to give them a bit of room, you know, roughly round it to the nearest 100. We got that by that, and pick the widest points. So let's see, what is the widest point? So we've got 250 here. 256. So let's go with this bottom width here, drag it up to the top. And let's do the same thing again. So we've got 256, so let's change that to 60. So these overall measurements here are, you know, generally speaking, you're just doing an assembly view. You're just rounded sort of thing. If you're doing like a, you know, something that's quite precise, you obviously just leave the precise measurements on there. Just for what we're doing, I'll just round it up to the nearest 10 mil because it was, you know, a couple mil off anyway. So if you just think about, you know, if you're showing someone this fire, you're going to put it on trade me or whatever, you'd round it up to about that and just say that's the, you know, rough dimensions of it. And yeah, in the case that those dimensions are important, obviously, just put them what they're supposed to be. So let's do a sheet with the body, and type in body there, off to the side, and let's place some views. So we'll place go to base, down to here, find the body. So I'll put a nice isometric up here, so I'll try and keep it all around the same way. And let's just say 1 to 5, 1 to 5, not percent, would be good. And I'll just click on that and edit it. And make sure it's filled in. It's got the tangent edges on there as well. And this will be interesting. So if we go to base, go find that part again, rocket fire body. And if we go to flat pattern, so it won't let me do a flat pattern because I never actually made the flat pattern for it. So I'm just going to save this. Rocket fire assembly IDW, that'll be fine. These two all. Now what I'll do is I'll close out. This is the safest way to do it. Close out of it. Get the body part. Just go create flat pattern. So go to folded part again. Make sure you save it. Close it and open back up that one. And you see it prompts you, it says there's some changes. You just go, yeah. And those changes affect these ones with the lightning bolt on them. So it tells when there's been a change in one of these components, and it gives you a little bolt to signify, oh, you need to sort of check this because it might have changed. So there's our body there. Let's go up to here, the base, and let's put it in there. And we want to see the flat pattern. So here we go, flat pattern. And I don't want to set that way up, so I'll click on this cube here a bit. And I'll do 1 to, say, 6. See how big that turns out to be. It'd be bigger than that. 1 to 5. 1 to 4. So maybe 1 to 5 was a bit better. Because we got that view in the corner. And we don't want to fill this in really. We just want to make sure we've got our edges on there. That's going to show our fold lines and everything. There's that body there, so let's just have a look at that. Actually thinking about that, I might just make that a bit bigger. Bigger the better. And if I just sneak that along here a wee bit, should be able to get away with it. Possibly make this view here a little bit smaller, be good. It's fine there. Now go back to the dimensions here, annotate dimension, click on the line, and see we've got 1189.57. It's as accurate as you want it to be, so realistically this thing, if it was 0.3 of a mil out, it's not going to matter lengthwise, so I'll just go primary unit 0, so that'll round it up to the no decimal places. So it's obviously depending on what you're making here as to whether how important it is that you get this exactly right. Let's click on that and we'll go 0. Same again because it was bang on. So move this out a little bit. So there you got your cut size on that bit there. So what it possibly will pay to do is maybe write that down there. So I'll do that as I go. And you could put that in the description on the exploded view if you wanted to. I'll just go C-S 1190 by 500. And that's just like a side note there. I could even put this up in here if I wanted to. Now, what gets a bit trickier is trying to dimension all these smaller parts here. So let's do, say we've got this bit here, we want to sort of dimension where the slots, like how they're done. So what we can do is go up to place view, and we could do a section, a detail view, sorry. Click on that, click on this view, and it's come up with this little thing with an A in it, you see. And what I like to do here is do a cutout shape as smooth. You can do a square fence or a round fence, just do a square one. And you click in the center of where you want it, and you drag it out like that. Make sure you got enough detail in there. And click again. And then we'll put it over to the side here. You can see it's already sort of put a label there and a scale there for it, so that's all good. But what you might want to do with this one is just drop that down lower. Now we can put some dimensions in. So let's say we want to know centrally. So we've got 100 from the edge. And even after the dimension, we can put centered, something like that. Something that makes some sense. And let's go from the center of that bit to the center of that bit. I'll line that up there. And what we can do with this one is just write TYP, typical, round that up, just to save a bit of space because we don't need the 0.00 whatever. So that should give you a bit of an indication there. Now let's do size of the slot. So let's drag this out here, 3.1, and we can do a tolerance on that. So I do think we have to do one measurement with a tolerance, so plus 0.2 minus nothing is good. And if I just hover over this, I can drag that measurement out here. So these are our tolerance. And let's do the depth of it here of 25. Once again, 00, so I'll just bring it down to that. So there could be, side notes in this drawing saying unspecified tolerances, plus or minus this. Usually you'd have something down there in the title block. Not really necessary for what we're doing here. And let's do another section view, another detail view. So let's do a detail view of these holes here. Click on this view, and I'll do a round one this time with a round outline. And I'll put that up here. Put that label down there. Good. Label up here. And now we'll do some center marks here. I'll go center mark of these two circles. And you can see how it's like solid, so it's not really ideal. So what we can do is just hold shift on that and that. And we drop down over here for the type. So it's just by standard. So let's try by ANSI. It's just made it smaller. Let's try ISO. It's just quite a small hole, so we'd have to go into the style and change it that way, but that's fine. All I'm going to do is click on those and change the color. I have to go into here, center line, and I go edit layers. Go down to where I had that center line one, which was this one. Click on that, make it red. Okay. So you can set these up. So usually if you're going to use the software for a long time, you'd spend, a couple of days just setting it up. Let's click on those two again, and we'll go down and we'll find the red one we just did, which is right there. Now we've got two red crosshairs, and we'll put a dimension from here to the bottom. Ended up being 13.1, so that's fine. Not that important for this, so we can just go 13 will do. And same thing again, do one from here to here. It's just tidying it up a wee bit really. And easiest way to do the diameter thing is you can do it for dimension, but then you have to change all these styles because the way it does it standard doesn't look very good. So I just go to a text leader here, click on the circle, click out to the side, right click and continue. Then I'll change this text to 5mm. So you've got a whole bunch of symbols down here that you can use, but I will just use diameter 8.0. And then what we can do is put typical there as well, to say they're all the same. And that looks a lot better than the standard one, which I'll show you. Again, you have to change this in your settings. But it just does it like that, which is fine, but it sort of gets in the way sometimes, or it goes on a weird angle. And actually looking at that, it looks too big, really. I'll drag over there and just drop it down to 3.5. So there's your two section views there, your two detail views. Overall, what we can do here is just do drop in some more dimensions. Let's do some notes for the folding. I'll click in here and go text. And I'll go fold up 90 degrees, like so. And if I hover over this, click it, get that blue arrow, I can turn that around. 90. Further out, the easier. And I'll stick that there. Have to click away from the view to paste it. Like that. And now we've got some fold detail on there. I'll just go back and look at this. So, yep, got some notes around it. You want to put some notes on your one. 4 required, 3 required. You just want to make sure you've got enough detail that someone could pick this up and make it. So I've got my radius labeled there just for a text. Positions of your holes and everything. So I'm not going to go through and redo every last little bit of this one. It's just an example of the techniques. So what you guys need to do is keep going through it. So you need to do your exploded view, do that first like this, your assembly view, the overall dimensions, you can round them up a bit. There's the body. So you would need to put more dimensions on it than that, so enough to actually be able to make it. So you'd want to put some like center marks in these holes and put measurements to where they are. I think you guys, you've seen enough engineering drawings, you could probably do that easy enough. So say I've got the body here, the next one I might do the base, next one I might do the mid bit, and then the slate, then the foot, or whatever, It depends what you've drawn. So just make sure you've got every single part drawn and it's on a bit of paper and just make sure you've got all this details right. So, 1 out of 8, 2 out of 8, scale here, your parts list, etc., etc. So once you've gone through and done all your parts, what we can do is I'll just make sure I save it first, as I always do. Come up here and go File, Export to PDF, and just save it. You always need to check this option though, actually, sorry. So go to Options and go All Sheets, and that'll print them out in one big lot. And just go Save. Now if I go to that folder, you see it's come through as a PDF there. And one thing you'll notice is when it does come through as a PDF, it tidies up all these line weights and everything, so it actually looks a bit nicer than it does on the CAD. And yeah, so especially with these like flat patterns and stuff, looks a lot better there than it does here, or similar. Sometimes, just tidy up the lettering and things like that. So you need to export it to a PDF with all your views on it. So I'm going to be looking over them and making a judgment whether or not I could come along and make what you've drawn. So the more the better, really. You want to be a bit kind of sensible with them though. You don't want to have hundreds and hundreds of dimensions just to for me to figure it out. You want to make it so that it's conveying the most important information, and you've got to have notes and things along it so I know exactly what you're doing. Another one thing I did forget to mention just then is we need a weld symbol as well. So you need to go into your assembly and you've got your welding symbols here. So you need to just play around with what sort of weld you want to do. You can never, Google what sort of symbol you need. Let's just say this is a 3x3 fillet, and say that'll do. There you go. Just make sure you have one weld symbol in there. From this point, so once it's all on the paper, last thing we need to do is you probably want to go into your folder, and I want to just put a new folder, DXF will do. Come back into this, go back to your assembly again. Double click on it, say go to flat pattern here. Click on the face and right click and go export face as DXF in your DXF folder. So we'll call that body body. Go back to your folded part again. And you can close this one. Go to your mid plates or whatever you've drawn. Same thing again, click on it, export face as DXF. So this one's rocket fire. On there, close out of that. Slate. Got the base here as well. Let's do the same thing. Save everything. I'm going to close out of Inventor now. So open AutoCAD. Go back into your folder. So there's the base, and let's just keep opening them all up. Body, foot, So you want to get all your parts and you want to chuck them all on one sheet. So I'll probably start with the body here. And what I'll do is I'll just draw a rectangle, first corner point 0, 0. That'll start it at the origin, which happens to be the bottom of this part. And go 1200 by 1200. Grab your part. Oops. And what we need to do here is we just need to make sure this thing actually fits on the sheet, because you guys get a sheet 1200 by 1200. So I'm just going to grab all the parts individually, go to clipboard, and it'll be up to you guys to lay them out and just make sure it's all going to fit. When I get the files off you, no, won't save change to that. We'll run it into we'll put it through the plasma cutter software itself, which will nest it a bit better than this. So it's not too much of a problem. But you do need to make sure all your pieces actually fit. So whether you actually do this, what I'm doing here, and lay it all out onto a 1200 by 1200 to make sure it all fits, or if you go off the cut sizes, either or, it has to fit your bit of material. And if you've gone over, you need to source a bit more of your own material, or if you're not using the material we supply, yeah, we can work with that. I mean, we supply free mill just because that's what I asked for. So we have to use free mill in it. It doesn't necessarily have to be entirely of 3mm. So that's the whole project, really.